Okay, in these problems, we will start doing a little bit of statics. Just use what we learned in statics to find the stress in a cable. So we have a beam that is quite heavy. The beam has a mass of 500 kilograms. Don't forget that kilograms is the mass, so to have the weight, you need to multiply by 9.81. So the weight will be 500 times 9.81. That will be, oops, 4,905 Newton. Don't forget to convert mass to weight um, when you have international units. So, and what we know with the beam is uniform. Remember what that means, uniform? Uniform, it means that the weight is spread everywhere uniformly. So your weight, let me throw it in blue, will be in the middle like this. The weight is always vertical. Remember, don't put it at the like perpendicular to the beam. The beam has an angle, but the weight is vertical. And we have some information of distances. So in our case, we have a distance L, the beam equal 5 meters long. The angle is 20 degrees. And the height is 2 meters. Yes. Here we go. And you will have some different numbers, of course. So the question is, what are the stress in the cable there inside this one? So what we will do to start with, free body diagram. So we will do the free body diagram of the beam. We have the beam like this. Oops. We have some forces that we know. The only force that we know is the weight. That is at the distance from there. We will need that distance. So that will be the 5 divided by 2 times this angle, so time cosine 20. Because remember, we will need the moment. We will do an equation of moment. And for the equation of moment, we need the perpendicular distance to the weight. We have two unknown forces at the pin connection. And that's why we will take the moment about that point. Okay, let's call that moment O. And we have a force P. I call it P because it's a pulling force. I'm pulling on the cable. There's a smooth pulley, so smooth pulley means no friction, so the force P after the pulley and before the pulley is the same. And that's what we know. And when we do the moment about O, let's see. I will get you what we need to find. When we do the moment about O equals 0 because it's statics, we will have the weight minus because it's negative, it's turning in the negative directions clockwise, times the distance. And the P is rotating in the positive directions, but we are missing some information there. So what we want to do to make it easy, let me draw it in, we want to use this distance L, that is 5. So we will use the complement of P that is on this axis. So we need to find this angle alpha. So we will have plus P sine alpha. So that will be this complement of P, vertical complement of P. Oh no. Let me put it in a nice color. Oops, purple. So we will want to find this complement P. Let's call that the P sine alpha time the distance L equals 0. So we can find P. We are missing alpha. So let's find alpha before we can solve for this equation. Okay, so I want to find this angle alpha. We are missing one distance there, that is 2. So to find angle alpha, we would love to do a sine law. Okay, so the sine law, we will need the opposite angle there. That's the only angle that we can know with from theta, and we will need the one of the distance on the opposite angle. Okay, so let's see. We have something like this. Take your time to do your sine law. Okay, we have 2 We have 5, and let me do it something. Let's look a little bit more at the scale. 2, 5. We know this angle, so we know this one is 20. So we know this one is 70 degrees. And the angle that we want to find is alpha there. Okay, so before the sine law, we need the cosine law. I know that will take some time. Oh, I add that. I touched the bottom of my computer and it make me this. So let's find x. Cosine law first. We have x squared equal 2 square plus 5 square minus 2 times the 2 distance 2 times 5 times cosine 70. Don't forget the square. So when you solve for that, I get 4.71 meter. So this is this one. And now I can do my sine law. Oops, second step. Sine law. That will give us sine 70 degrees divided by x equal sine alpha divided by 2. So you will find alpha equal the inverse sine of sine 70 times 2 divided by 4.71. So we got alpha equal 23.5 degrees. Okay, so this is the value that we were missing that we will add to our equations, and we have also L. So let's now find P. We have P equal W divided by 2 cosine 20 degrees, and we divide by sine 23.5 degrees times the distance L, that is 5. And remember the W, that was the 49. Okay, 4905 times 2.5 times cosine 20 degrees divided by sine 23.5 degrees times 5. A good little review of statics problems with an equation of moment, right? We get P, that is the force in the cable, of 5,772 Newton. And we have one last step, because what we need is not the force but the stress. So we go grab the formula for the stress. So let me do this one there. Sigma equal the normal force. In our case here it's P divided by the area of the cable. And we know that the cable is 5 centimeters. Remember, we need to use millimeters square for the area. So sigma equal 5,772 divided by pi times the 5 centimeters, so 5 times 10, and divided by 2 because this is the radius square. When we get that, we get 2.0, not 2.9. Did I change the value? 520 degrees. Yeah, no, that's correct. So we get 2.9 megapascal. So this is the answer for the beam at 20 degrees with 500 kilograms and a length of 5 meters and a pulley that is attached at 2 meters. So you can see how if I change the distance from the pulley, the weight of the beam, or even the angle, that will change the sigma. And you will all have different numbers, so we could compare and see what has the most influence on it. Hope that helps. Bye.